Alright, this is the second video of me going over Unit 3, Exam 3 practice problems. We stopped after number 5. Let's go from number 6 through, let's do about 5 or 6 more. Let's go up to number 12 in this video. Okay, so number 6 through 12. Number 6 is a word problem. Let's take a look. Forge welding is a process in which two pieces of steel are joined together by heating the pieces of steel and hammering them together. A welder takes a piece of steel from a forge at 1600 degrees Fahrenheit and places it on an anvil where the outdoor temperature is 50 degrees Fahrenheit. The temperature of the steel in degrees Fahrenheit can be modeled by, I'm going to highlight this, T equals 50 plus 1550 times e to the negative 0.05 t. This is a negative rate. It's a going down function. Well, because the temperature is going down as it cools, right? Where t is the time in minutes after the steel is removed from the forge. How long will it take for the steel to reach a temperature of 100 degrees Fahrenheit so that it can be handled without heat protection? Round to the nearest minute. So we're going to wait until it turns into, the temperature turns 100 degrees Fahrenheit. So set up the equation. 100 equals, because that's the temperature they're giving you, right? 50 plus 1550 e to the negative 0.05 t. We're looking for t. They're asking you how long will it take. They're asking you to find t. So after reading this problem, we were able to set it up. Let's go ahead and solve this equation together. What do you do to both sides? Subtract 50 from both sides. You get 50 equals 1550 times e to the negative 0.05 t. Now divide both sides by what? Divide both sides by 1550. To cancel this out, let me see if 50 divided by 1550 is a nice number. 50 divided by 1550. Not really. It gave me a decimal, which I'm going to just go ahead and simplify into a simplified fraction of 1 over 31. And that equals e to the negative 0.05 t. I'm not going to round to anything, in fact, in the middle of a problem. Until I get my final answer, I'm going to just keep it accurate. And 1 over 35 is just a simplified fraction of 50 over 1,550. And if you want to keep it as that fraction, that's okay. Nothing's wrong with that. Now, let's solve this for t. When you're solving an exponential equation with e, what do you do to both sides? Take natural log of both sides, right? If you take natural log of both sides, well, natural log of 1 over 31 is that, but natural log and the e will cancel, well, I shouldn't say cancel out, it turns into 1, and the power comes down before it does that, so I will have that down. Let's go ahead and divide both sides by negative 0.05 to solve for t. Since you learned how to solve these logarithmic or exponential equations in section 3.5, 3/6 is just a matter of setting them up correctly. Now, let me type in natural log of 1 over 31. Divided by negative 0.05. And it got me 68.679. But if I round this to the nearest minute, that's what they wanted. I have to wait, 69 minutes. So the answer is going to be 69 minutes simply by solving that equation we set up together, okay? So I got a couple application problems on this exam for you because I do want you to set up your equation and just want to give you some applicable questions that are meaningful. So I think this one was a good one. Let's talk about number 7. This is something that we actually did before spring break when we were actually in that classroom together. Below the entire graph of function f, is f one-to-one function? Explain. Well, to be one-to-one function, it better pass the horizontal line test. And looks like if anywhere I draw the horizontal line, it's not going to touch more than, I mean, it's kind of, the slope is kind of small here, but as you can see, this function is increasing. It's going up, going up, going up, going up, right? It's never flat anywhere. So this function is, yes, it's one-to-one, and explain it passes the horizontal line test. And that's a great reason to give. If you are given a graph of a function, if you do a quick horizontal line test, and if it passes the horizontal line test, then it is a one-to-one function. If f is one-to-one function, graph f inverse on the same coordinate system as f. Now, I'm just going to go ahead and plot 3 points. The one that I see is here, -5, -3, right? And this one is at 5, -2, and the one up there is 7, 4. If f has x coordinates -5, 5, and 7, and y coordinates -3, -2, and 4, f inverse will have x coordinate of -3, -2, 4, and the y coordinate of -5, 5, and 7. Simply flip the x and y, right? That's how you make the inverse. So let me go ahead and plot these. Plot -3, 5, -3, -5. 3 to the left, down 5. Here's the first one. Next one, -2, 5. 2 to the left, up 5. Ah, your exam just got created. Awesome. And then 4, 7. 4 to the right, up 7. There we go. And then I'm going to go ahead and connect them. And as you can see, remember, I don't know, was it before spring break? Oh no, in fact, not really. This is something that we did immediately after the school was shut down for the corona, because of the corona. But take a look. What am I drawing? That's my line y equals x. Do you see a nice symmetry here? So the function and its inverse function are symmetric with respect to this line y equals x. So this is very good. So that's how you will graph an inverse function using just a couple points. Okay, and this looks great. All right. Let me go ahead and go over domain of logarithmic functions, okay? So, domain of log, I think I kind of gave you the rule there earlier. Make sure the argument, what's inside, is greater than 0, okay? So let's set that up. 12 minus 2x better be greater than 0. Because if it's less than 0, it's not a real number, okay? Or equal to 0. Can't be equal to 0. Just because... Try to erase, let's say, just a random base of 10, because this is common log. If you raise 10 to the whatever power, like x power, can you get a negative number? Can you multiply 10 many, many, many times and get a negative number? Not really, right? Can you raise 10 to the some kind of power and get a 0? Not really. So that's why I just had to rewrite this in exponential form that we are more comfortable with. But whenever I'm asking you to find the domain of a logarithmic function, just grab that argument, say that it's greater than 0. Let's solve this. Subtract 12 from both sides. You get -2x is greater than -12. Divide by -2. What do you get? X is less than +6. Don't forget to flip the inequality symbol here. We just divided by a negative number. So in an interval notation, this is going to -infinity, and it's going all the way, well, as close as possible to 6, but we will use a parenthesis, okay, because it's not going to be at 6, because at 6, the argument will be 0. Now let's set up the second one. X squared minus 16, we want that to be greater than 0. And this one, if it's an equation, you can add 16 and take square root of both sides. But remember, this is a polynomial inequality. We learned this in the previous unit, and what we do is that we factor this. And then find the boundary points. The boundary points are -4 and +4. And I'm going to draw the open circle because it cannot be equal to 0. Now check some values. To the right side of it, check x equals 5. So if I do 5 squared minus 16, will that be greater than 0? Or let me just do the signs the way that I did when we actually went over 8 point, what was this called? 3.6 in this lesson together. Let's plug in 5 into this factored form. X minus 5 turns into 5 minus 4. 5 minus 4 times 5 plus 4. That will be +1 times +9. So this is positive over here. That's positive over to the right side of 4. Now, what we can use is by now, you know about the multiplicities of these zeros being all odd. And the odd multiplicities, the graph will cross. At least show me one though. At least show me how you know the first interval has a positive or negative sign. But you can also show me, check, this will be a nice one to plug in 0. 0 minus 4 times 0 plus 4 turns into negative 4 times positive 4. And negative times positive is negative. But at this point, I know you know about the multiplicity and the behavior of the graph at these x-intercept based on all the evenness of these multiplicities. So if you want to do that, that's okay. Now, what were we looking for? We were looking for intervals that are greater than 0. So here we go. The ones with the positive are going to be the intervals. So the domain of this function is, let me write it down here. Domain of g of x is from negative infinity to negative 4, union 4 to positive infinity. And we have to skip the ones in the middle because the ones in the middle will give us a negative argument, okay? So just kind of wanted to stick in that review of solving polynomial inequalities on your exam 3 as you are preparing for your final exam. Wow, can't believe the very next week now, almost, right? So it's kind of going fast, but remember, everything will be open notes from now on. I mean, not now on, since Corona. So don't worry too much if you cannot memorize everything. As long as you remember, oh, I've seen this. I've done this before. This is in my notebook. And if you need to go back and look at it, I think that's okay. Because sometimes this online learning can be a little bit challenging. All right, let me do 3 more in this video and then I'll stop. Use the definition of one-to-one function to determine if the function is one-to-one. Hint. It's okay for you to sketch and use the HLT, horizontal line test. So great review again. Let's graph this p of x equals x plus 3 in absolute value notation. Now remember, absolute value functions are in what shape? V-shaped function, right? This is a V-shaped function. And you already know, you draw a V. We'll do it together. Now, look at the translation of it. Adding 3 will move the graph 3 to the left, right? So your vertex, your vertex is going to be, I call it vertex, but then that pointy end is going to be shifted 3 to the left over here. And then you will have a V shape going up to the left and going up to the right. Now imagine doing a horizontal line test here. Draw a horizontal line. Ta-da! Did it just pass the horizontal line test or fail it? It failed it. Notice it touched 2 points on this single horizontal line. So you can say this fails the horizontal line test. Therefore, not a one-to-one function. We can also do this algebraically. You can plug in 2 different x values in here. For example, let me give you maybe, how about, what if I ask you to find p of, let's say, negative 5, okay? What is p of negative 5? That will be negative 5 plus 3, right? And that turns into absolute value of negative 2, right? Which is what? Positive 2, right? What if I ask you to find p of, suppose, negative 1? Then the function will be absolute value of negative 1 plus 3. I meant to close the absolute value symbol, which is absolute value of positive 2. Now, absolute value of positive 2 is still positive 2. What I just got is that p of negative 5 does not equal to p of negative 1, right? I put 2 different inputs in there, but I got... No. That's not what I want to say. I want to say negative 5 does not equal to negative 1. But p of negative 5, which came out to be what number? 2, actually equals p of negative 1, which also came out to be 2. So this explains that because of this, what we are seeing is repeating y values, right? If you plot these, you will plot a point at negative 5, 2, and you will plot another point at negative 1, 2 in this function. So when you have repeating y values, this is not a one-to-one function because this y value is paired with 2 different x values. So 2 different ways to do this, but I think the easier way that I will think is fine is just sketching a quick graph and performing a horizontal line test, okay? Alrighty, let's look at number 10 together. You know what? 10 will be a good stopping point because 11 and 12 have to do with writing inverse functions. And this is kind of verifying the one that we write. So let's go ahead and do number 10 and I will stop this video. All right, g of x is given. It's a cube root function. They want you to write g inverse of x. Remember how to do that? We switch the g of x to y equals, and then we're going to switch x and y. X equals cube root of y plus 2 divided by 3. To undo cube root, what will you do to both sides? You're going to cube both sides. If you do that, you get x cubed equals, no more cube root, bye-bye cube root, y plus 2 divided by 3. Let me move my work over here. So x cubed equals y plus 2 divided by 3. And the next step is to multiply both sides by 3, right? So you get 3x cubed equals y plus 2. What's the very last step over here, guys? Get rid of that plus 2 by subtracting 2. I'm bringing all these colors onto this problem. 3x cubed minus 2 equals y. And then let's go ahead and rewrite this as a beautiful g inverse of x in inverse notation. And this is the inverse of g of x. That's how we write it, using a whole bunch of inverse operations, right? Now, to see whether this is really an inverse function of g, what we have to verify is that their compositions give you x back. So I'm going to do this one first. What is g composed with g inverse of x? That is them asking you to find g of g inverse of x. Okay? I'm going to do this and see if it comes out to be x. Remember how we did this to verify whether two functions are inverse of each other. So if my answer is correct, I better get x on part B and x on part C. All right, so g of g inverse of x is 3x cubed minus 2. I'm plugging this into the cube root function. So the big picture is cube root of x, but x is 3x cubed minus 2 plus 2 over 3. Now what we have to do is simplify this carefully. Which one simplifies first? Negative 2 and positive 2. Once that parenthesis is gone, the negative 3, a negative 2, and this positive 2, these will cancel out and give me 3x cubed over 3, right? Now, what cancels out next? Notice that the 3's will cancel out. So I'll get cube root of x cubed. Now, finally, cube root of x cubed is what? X. So that's it. It came out to be x, and what I want you to do, if you're taking this paper pencil exam, and I think some of you will have to do this on, yes, all of you will have to do one problem like this on Alex, but unfortunately, I won't be able to check your answer. If you can, please cancel out one thing at a time instead of doing this, because I've seen somebody doing this before. Doop, 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 doop. Don't do that for me. Do one step at a time to see if things will cancel out in a nice order, okay? All right, let's verify the other way around. This time, we're doing g inverse of g of x. So plug in the original function, the cube root function. By the way, what was it? Oh, x plus 2 divided by 3 into the inverse function that we just wrote, the pink one. So that's going to be 3 times cube root of x plus 2 divided by 3 cubed minus 2. I have to simplify this. So don't cancel out everything in a single line. Let's see what cancels out first. Notice this cube root and this cubing cancels out first. Then I will have 3 times x plus 2 divided by 3 minus 2. Then what cancels out next? The 3 cancels out. Therefore, I will have x plus 2 minus 2. And then this is when the plus 2 and the minus 2 cancels out, leaving us with just x. What we just did was we wrote an inverse function, and then we actually verified it by checking both composition. So they are inverse of each other. This is what I want you to try, what I want you to do on your exam 3. But it's going to be very, very good if you can please show how things cancel out step by step instead of just doing, you know what I mean, like do. I know eventually they will cancel out and give you x, but show me which ones cancel out first with which one and everything, okay? So I think that's a good stopping point for the second video. We went over page 2 and page 3. I will be back and go over some more fun problems in the third and hopefully the fourth video.